Hi, I'm Randy Brannon with Roanoke Landscapes. Our company has been in business here in Roanoke, about to celebrate our 20th anniversary. Out of those 20 years, we've been designing and constructing retaining walls for about 18 of them. These run in the range from natural stone walls to segmental block walls and finally poured concrete walls. We've recently completed a project that included several natural stone retaining walls that we're quite proud of. We videoed this project from start to finish. You can see almost all the elements that go into building a natural stone wall. And following that video are some Q&A that maybe fill in the blanks for you if you really have an interest in how this goes together. We hope you enjoy the video and continue watching. I'm today out at a natural stone retaining wall. We're here in Roanoke. This is made from Virginia mountain stone, recovered just a few miles from here from the New River Valley. This stone, it's sandstone, and you can tell it has a lot of color in it. Most of this rock has been run through a splitter, a hydraulic splitter, and that's how we get at least one side with pretty much a straight, what the masons call a face on it. And we do that to get a dry set, what we call in the industry a dry set look, meaning you don't see the grout, very little if at all. You can see the joints to give it character, but the grout is mostly behind, in the back of the joints, behind the rock. All this rock is 4 to 6 inches thick. There's some ballast riprap sometimes in the middle of it, and then faced, it's backfilled here where this is going to be a patio where the caterpillars sit and be a patio, and then a seating wall which will be another 2 foot high. And of course the seating wall you view from both sides, in which case we'll have this same look on the inside. And then a molded cap, manufactured cap to go on top of it for the seating and to finish it off. This is kind of like building a footing on a building or on a house. You need to go down below the frost line to make this stand up to the years of freeze thaw and what have you. So these walls are down about 15 inches. The footing is the bottom of the footing, and then we bring the footing up to the top of that trench more or less, and then we start building the walls. So the walls, the footing's not poured concrete. We use limestone, riprap if you will, and build the footing from that. There's also drainage in behind the wall, be a piece of pipe that vents through the wall if you can't get it out the end, but you want to be sure you relieve hydrostatic pressure behind that wall. If not, it could cause a problem. The rule of thumb on these stone walls is you need half the width, half the height of the wall at the base for the width. So for instance, if this wall right in here is 4.5 feet tall or somewhere in that neighborhood, so our footing is a little better than 2 foot front to back thick. Failure to do that eventually will cause something to move. If anything in this wall moves, it's failed. It's contrary to a segmental wall, a man-made wall. Those are not meant to be perfectly rigid. If there's a little bit of movement there, it's probably imperceptible, but it really doesn't hurt anything. Anything moves in this wall, it's failed. Probably doesn't fall down, but it's failed. There's several reasons to select stone wall, natural stone wall, I think. first and maybe most obvious, it's hard to beat the natural look, the beauty of natural stone. Some of the man-made products, including the veneers, are great, but most of the time you know that it's not a natural product. Some people wouldn't have anything but natural stone. We don't do as many of these walls. There's not as many of these walls built today as what there was 30, 40 years ago. Part of that reason, the manufactured walls haven't been around all that long, or they were very rare back then. Now there's a boatload of manufacturers with different types of block, different looks, different connection methods, and comparatively, in most cases, the manufactured, the SRW wall, which stands for segmental retaining wall block, are cheaper. There's probably a little less, well, not probably, there is a little less labor goes into the construction of those, less footing involved. That's the primary difference, is the labor on constructing them. We're going to have lights on this project. You can do regular post lights on the ends, or if you have columns, we're going to use sconce lights, hardscape lights that slip up under the lip on the cap that goes on the seating wall, of course on the inside, and for aesthetic wise, and to be able to use it in the evenings too. I mentioned the look on this wall with the dry set look. That's one of two methods anyway to lay these walls. The other we call wet set, meaning you see more of the grout lines. Usually, a lot of times you're not using such a straight edge stone, you're using more rounded types, which is you just can't hide the joints with the rounded stone like you can with the square cut stone that's even on the end. So but it takes, with that type of stone, the wet set look, it takes less rock, a little more grout maybe, but less rock, way less labor. You can hear the fellas chipping away in the background. Even though these stones have been split on a machine, you still have to work them, shape them, size them a little bit to get this tight look. Not necessary with a wet set look. Most of the walls you see are the wet set look with the bigger grout joints in them. This is tougher to do and quite a bit more expensive. This type of lay is at least half again as expensive as the wet set, maybe even more than that. Just to give you an idea, this wall is somewhere around $50 a square foot installed, and that's not counting the footing. And if you're doing seating wall or a parapet wall, meaning exposed on both sides, it's not a retaining wall, you're actually doing two walls. It doesn't quite double the cost, but it does make it more expensive naturally when you're showing both sides of it. These are a little more expensive, everything else being the same, a little more expensive than the SRW walls, the segmental walls. Part of the reason is, as I spoke earlier, the footing on this has to be adjusted on these natural stone walls, adjusted to the height of the wall. Higher the wall, the wider the footing. Of course, it has to go, if you go to the frost line in this case. With the segmental walls, the footing is pretty much a standard, given a constant for shorter walls and taller walls. If you're building one 2 feet or if you're building one 10 feet, the footing is still the same. You go down You don't even have to go down to the frost line for that. Again, if they move a little bit, you know, if you had a little frost heave, not a problem. It's probably not perceptible, but the wall doesn't lose any strength. So if you do a wall out of natural stone that's 10 foot tall, then you need a footing somewhere around 5 foot wide at the bottom. So all that depth, all that breadth has to be made up with stone. You don't have to use the decorative mountain stone. We use riprap, which is, you know, considerably less expensive, but you still have to put it in there. It's not a neat lay like you see here. It's mostly thrown in rather haphazard and mortared in. Still takes time, still takes material. So the footing, even the excavation for these walls, obviously, is greater the taller the wall. With the segmental walls, the footing is about 2 foot wide. There's a little bit of limestone goes in the bottom of that, and then you construct the wall. Again, even if it's a 10, 15, 20 feet wall, feet high, the footing is pretty much the same. You do have to go in the ground more with the taller walls to keep them from pushing out at the bottom, but width, the breadth of it, is the same for a shorter wall as a higher wall. Part of the strength to these walls, which is the case for the man-made walls and these natural stone, is the putting a batter to the face of the wall. Batter meaning a setback or a lean back to where the weight is. So we almost always build ours with some lean to it. If this was plumb, that level's showing plumb right there. So at the bottom, it's probably almost 2 inches of batter to this wall at 3.5 feet, and be a little bit more when we top it off at that 5 feet. But that adds to the strength significantly. The man-made walls have the batter built into them, so you almost have to do it that way unless you alter the block. Again, that's for strength. On top of the wall, we're going to have lighting on these on the seating wall. So the top of the wall is about here. The seating wall will be up here with a molded cap on it. The lighting, most of the lighting used outside here is low voltage landscape lighting, 12 volt. You know, most of it's LED right now. So they have what they call sconce lights, hardscape lights, and we'll slide them in. About the last thing we do, slide them in under the cap before we mortar the cap to the top of the wall. So you can put them on the inside or outside. These folks are going to have theirs on the inside. So sconce lights like you'd have in the house, it just shines down the wall, mostly for accent. With this low voltage LED stuff, it's only a watt or maybe 3 watts at the most, not very bright. There's no columns on this wall, so we don't have any post lights, any 120 volts in this case. The wire for the lighting, we're going to run down the center of this wall when we finish it at the top, so we'll leave a little groove down the center of it. We'll chase that wire down that groove and tie it off to the respective lights. Transformer will be mounted maybe on the back side of this wall, so it's out of sight. Transformer takes house current 120 down to 12 volt. And again, with the LEDs, you can power a boatload of lights from a small source. One transformer will do a lot of them. This is the back of the wall. Thought we'd give you a look, see what we're talking about in behind here. This is mostly riprap, limestone, rough limestone that you're looking at straight from the quarry. Obviously, it doesn't look anything like the front. This is the back of that dry set wall we were just talking about. The we don't try to, no rhyme or reason what's behind it if it's going to be, you know, covered up. The patio comes right through here, and it will stop at the top of this retaining wall, and then there'll be 2 feet of seating wall on top of that. So again, all this will be hidden. You can kind of get an idea here. What you're seeing is the bottom of the retaining wall, but you're not seeing the footing. There's still 15 inches or so of footing under where I'm standing right here. Again, went down to the frost line. You build this above the frost line, it's subject to having it fail due to frost heave. You know, nothing's going to happen in a hurry, but to be properly built, you go below the frost line. We're not going to put drainage in behind this wall, where we would if this was area that's going to be reclaimed here, was going to be grass, turf, or a bed, or something the water would penetrate through. We would have some drainage in behind this wall, through the wall. Since this is going to be a hard surface here, we're going to pitch this, hopefully, where the water runs around these walls rather than make a puddle in behind it. But ordinarily you'd see pipe in here if it was something that the water could get to, perforated pipe, and then we run it out through the wall someplace. One other thing I might mention is if there's more of a load than what the flat area is, for instance, if this wasn't going to be a patio, if this was a parking lot where you're going to have cars and pickups parking in this area, that's called a surcharge, as is a hillside, a slope behind a typical retaining wall. Instead of being flat, if you have, you know, mountainside, hillside, that's called a surcharge, and that's felt by the wall back for so many feet behind the wall, depending on the height of the wall. So you have to build your wall according to any surcharge that might be going to be presented once the wall's built. So the standards I gave you on the breadth of this wall changes a little bit with a surcharge. So is the case with the segmental walls. You do things a little bit differently. You have to have a little more support, but some folks might not think that's much of an issue, but it can be. I have seen a couple of these stone walls, one that was every bit of 20 foot tall, that didn't have enough breadth to it, didn't have a mass, with a hillside behind it, and it probably 20-25 years after the thing was built, the folks that owned it came out one morning and the whole thing was laying in their backyard. It had rolled over as one sheet, and when it hit the ground it just broke all the pieces, and they called me out to look, see what could be done, or how did they replace it. But I could tell it was hardly any wider at the base than it was up there at 20 feet tall, which it was designed to fail, unknowingly maybe, but just you got to do a little bit of engineering on either of these types of walls rather than just throw them in the ground. We have built walls out of limestone. Doesn't look like much from this shot, but a pure limestone wall laid up properly is not ugly. It's pretty nice look. We've also done them out of granite. Limestone, you get gray and different shades of gray, maybe a little bit of brown with it, but there's not a whole lot of color in the limestone. Same way with the granite, it's kind of has a greenish tint to it, speckled, but there's not a whole lot of variation in the color like you get with the sandstone. I hadn't talked about the permitting required to do these walls. In Roanoke City, you're required to gain a permit from them on any wall that you build, no matter the height. When you get to a 4 foot, 48 inch level or higher, they usually require a sketch. Once you get above about 72 inches, they require an engineer, a professional engineer, to do the design and, of course, put his seal on it. You can tell from the breadth on this seating wall, it's not near what the retaining wall was from the earlier video there. This is about 11 inches wide, something like that. The seat that goes on it is 14. Again, this is not retaining anything, so it's mostly here to just as an aesthetic and functional in a way of being seats. So there's no pressure on this as opposed to the retaining wall. If you recall, at the breadth at the bottom of this retaining wall was about 2 feet. A little more here where it was a little bit taller, but there's somewhere around 50 ton of rock going in this patio, so obviously there's a lot of pressure against this wall, and code calls it, for being the breadth at the base half the height, so that had to be substantial. There is drainage through the wall in case to keep any hydrostatic pressure at bay. Our hope is to be able to crown this patio a little bit so the water rolls off the sides and doesn't get captured into the wall corner here. These tools are two of the most important for the guys when assembling these walls. As I said, everything has to be worked, every rock has to be worked by hand somewhat, some more than others, after it goes through the splitter, to be able to get a straight side, or we call it a face, to make these things look, the wall look rather smooth rather than in and out. If you just laid the stone straight out of the mountain without that, you wouldn't get near the chiseled look, you wouldn't get the somewhat orderly look, if that's the right word, that you get with this hand worked and split stone. And the joints are visible, the grout is almost invisible. We call that the dry set look. This is the pretty much the top of the wall. There is a 2-inch cap, natural stone cap, chiseled edges on it that sit on this wall. There's a groove or a slot, if you will, between these two walls where the wire would run to power those hardscape lights. Then the cap is applied with mortar. This I didn't mention, this is maybe the next most important tool to do these walls properly, at level. You have to finish the wall out level. Of course, it's a seating wall. You would see it, you would feel it if it wasn't level. It's also continuously checking for plumb, vertical. Without the level, you don't build a straight wall. This project is eventually a patio. As bluestone pavers go on this base that we're putting in here. This is crushed stone, compacted. This is a tool we use, a plate compactor, to install that, the floor part, the patio part. We also use it building walls for the footing on the man-made walls, SRWs, segmental retaining walls. Those footings are not concrete, they're made out of stone, similar to what we have here, or 57 stone. This compactor, once the gravel's installed, we run it in the trench where that footing is for that base course of stone, and it's not required to use concrete. gravel will do it, but it has to be compacted. And this is about 18 inches wide, so that fits the trench perfectly. Reversible, makes it a whole lot easier than doing the hand tamp. This base material is a limestone from local quarries here. There's an abundance of limestone under us everywhere in the Roanoke area, and no problem getting material to work with. It's a non-graded stone, meaning it's mixed sizes from 3/4 inch down to 200 mesh, which is a sandy, about like you'd expect sand to be. The reason for that is it allows this material to compact. If you use a clean stone, like, you know, all one size or so, it doesn't compact very well. Now, there is provision, you can do that if you arrange to do your installation that way, but especially in a permeable application, meaning you're going to let water go through your surface, even through your base material into a reservoir underneath, or possibly into pipes that's vented into a runoff area or a storm drain or something like that. This is not permeable, so we're using the we call it dirty stone, meaning it's just multitude of sizes there that allow to get compact. This is a screed bar / level that we use. All this material, when we get close to the finished grade, the guys are on their hands and knees with this screed board. You can see it's got the level in it to get the rule of thumb, or the industry says within 1/4 inch in 10-foot runs is what you're allowed to be out of being perfect. So you have to watch it pretty closely, and like I say, it's hands and knees work. Then on top of this, before the pavers or the stone is laid, is an inch of limestone sand. That lets you perfect the grade, the level on the finished product. Well, I'd like for you to see the base being installed here. You can see the guys raking on it. There's a minimum of 6 inches of crushed stone in this base, and because of the slope that we're working on over here by the wall, it's closer to 18 or 20 inches. All this is put down in 2-inch lifts and compacted with this plate compactor to approximately 98% Proctor. That's what they measure compaction with. That is to provide a base that's not going to go anywhere in freeze-thaw conditions. Normally you don't put pavers down or natural stone on concrete. You can, but that has to involve a grout, a mortar, and occasionally there's issues with water getting in under that on a flat surface, so we try not to do much of that. Preparing the sub base, which is under this gravel, which consists of getting rid of any organic that's under there, using a jumping jack or a rammer, if you will, to compact that sub base before you ever start putting down this main base. Sometimes we use a geotextile material under to separate the sub base from the main base, keep from dirt, clay, whatever, maybe eventually migrating into the main base here. But the key to this again is the material and compaction. Compaction, compaction, compaction is what the instructor says when you're taking the course to learn how to install these properly. So very important. I just wanted to show you how this compactor works for just a minute here. Okay. that's just the idea of how that works and what it does. That's about a $4,000 machine there, but it's invaluable. Just can't do it properly without that or something similar. So we've just completed our project here for these folks who've been at it for better than 2 months, I think. We started with the natural stone walls around the patio. I think you've got a pretty good visual on that. And we ended with this third wall. As you see here behind me, this is along their driveway. They were getting a lot of runoff, erosion from the neighbors, which is a little bit higher elevation here. So to stop that, that's where we constructed this wall. It also has lights on it, low voltage lighting, as we did around the patio. This was the second of 3 walls. We did one other small wall off their garage. The plantings are all complete. Grass is up that we sowed about 3 weeks ago, and the patio is all completed along with the steps in the rear of the house. So I hope this was informative to you and piqued your interest in natural stone walls. We hope to follow up shortly with another video on segmental walls, man-made retaining walls. Hope to see you then. Thanks.